This session is about a new concept. It's not new, it's actually started long back and it's very emerging field right now. As you know that AI is changing in this field and lot of advanced concept is coming. So with this, second, is it my screen is visible to all of you?
Yes, sir, it is visible.
Great. So see, these are the next era of AI and machine learning is quantum. Actually, see the today's world is looking for faster and accuracy in data processing and analytics. Um, the current there are a lot of advancement is happening in AI right now. You all have know about generative AI. See, every industry is looking for that type of business. Particularly, Gen AI is doing fantastic in his field. Um, it is the next advance to chatbot with human intelligence. So the next era is there are two big player in AI in quantum. One is IBM, next is Google, and they will very soon launch their commercialized product in quantum computer, be available in 2025 onwards. So we believe that in next couple of years, the entire AI business will be in quantum and quantum machine learning. So with this, little information, let me start this today's session. Uh, as I discussed with Bimlesh that what kind of audience I have today. So this is I have no idea that who are my audience today. So I believe some students and some working professional maybe join today's session. So this presentation is not only for technically but it's related to career, like how we will build our career in this way and how we will be established in your field. Uh, with this, let me start this slide. So, see, this is, uh, the concept is like, if we try to understand about the new concept, like generative AI or deep learning or this quantum machine learning, we need to understand what exactly artificial intelligence. So if I ask this question to all of you, what will be your answer? So in AI terminology, if we wants to define what exactly AI is, that the way we designing the machine or algorithm, if it is behave as much as like as a human, then it have the intelligence. So the definition of intelligence or knowledge is like that. If you collecting the facts, then it's a collection of information. If you have collection of information, it's called as collection of knowledge. Collection of knowledge is wisdom, and more you have wisdom, more you have intelligence. So with this principle, generally all kind of um, uh, all kind of tech applications are made. So you can see that there are a lot of industrial application already made in sense, comprehended, and act. Sense means computer vision, audio processing, like how you will visualize the things and how you get the analytics from the visions actually. Comprehended means natural language processing, knowledge representation, like you ask some question like chat GPT, that you apply some prompt and taking the prompt with natural language processing concept, it understand the questions and the knowledge associated with that related questions, you'll get the answers. And then it is act. One is your machine learning, one is expert system. So if you want today, if you want to buy any washing machine, advanced washing machine, front end or fully loaded, if you look in backside is washing machine, it will written as fuzzy logic based washing machine. This is called as expert system, rule based architecture. The amount of cloth, the amount of water, the amount of detergent what you put into the washing machine, it automatically optimize the motor speed, the way you can save the electricity. This is the application of expert system actually. Uh, uh, then I quickly come back to the concept of intelligence actually. What exactly it is meaning? Everyone, you register your email or register your any online form. There is a concept is called as captcha code. The captcha code is nothing but to understand that you are a human, you are not a robot, right? So this is not new concept actually. It's 1950 Alan Turing, who is the father of artificial intelligence, who just coined this test actually. It's called a Turing test. So when you put some letters with some numbers, it's called captcha. Captcha is today's captcha is also a little bit changed with numerical text. Also symbols are also included in captcha. That means a robot cannot understand the difference between a number and a letter. It's very difficult. It's that much robot have that not have that much of intelligence to differentiate between a number and a symbol actually. So when you apply any kind of capture, the backend algorithm can understand that you are not you are not a robot, you are not a child, you are not a bot kind of, and you are a human. So these are the security mechanism. All are bankings. If you go for any banking or any government officials or any suppose you apply for a job to any MNC, you should go with this test. And this is a test of artificial intelligence. And how we differentiate the AI scope. Right now, these are my domain where already I have worked. Maybe other domains are there, but almost all domain, all industry are now looking for AI, and they want to leverage their business, and they want to increase their ROI also. AI is what it flies in e-learning, transport, logistics, robotics, mine, constructions, manufacturing, e-commerce, telecom, and insurance, banking, healthcare, sports. A lot of scopes is there. So it starts with 1950, and now there are a lot of enhancement is there. Particularly if you want to make career in this, there are a lot of things are you need to learn. It's not a small thing; it's a very big thing. It's a kind of version you need to take. If you want to deep inside this ocean, you need to learn a lot of things in this way. I think TimesPro is taking care about this concept. You can learn a lot of things from them. Machine learning, computer vision, natural language processing, image processing, digital image processing, optimization, export system. These are the core branch of artificial intelligence. Without that, a particular AI system cannot be designed. And if you go for sub classification of machine learning, if you take any kind of domain, let's take a telecom domain where it's like let's take any telecom operator. What they're looking for, every day they want to adding more subscriber, adding more subscriber, adding more people into their service. They will make more money. So they will not liking to do any churn. So to predict churn prediction, customer churn prediction of customer inactiveness or activeness. Sorry, there's a station there. These are the applications of applications of AI. So if you look inside the concept of AI is it's you can segregate with supervised learning, machine learning, unsupervised learning, reinforcement learning, and you need to learn. These are the algorithms. Like if you're looking for supervised, you should have knowledge in convolutional neural network, multi-layer perceptron, adaptive network fuzzy information system, RL basis function, support vector machine, support regression, hybrid model. If you look to unsupervised learning, you should have knowledge in clustering, near, k nearest number algorithm, principal component analysis like that. If you go with reinforcement learning, you should have Q learning, SARSA model is there. So let's what exactly the skills you should know about the AI machine learning. Why I'm discussing these things before I come to quantum. These things are need to be discussed and need to be you should have some background knowledge about this. So if we're looking for a next level requirement of AI machine learning, a candidate or a developer should have knowledge of natural language processing. The person should have knowledge of computer vision, ensemble machine learning algorithms, unsupervised learning, clustering related, deep learning, reinforcement learning, and supervised learning. Generally, what happen, how we build a solutions, like we need to understand the business analytics problems, then you need to understand what exactly data analytics is there, and we need to understand that what data need to be considered for making any kind of solutions. And generally what happen when we get data, it's not kind of that much of clean data. We should do some lot of procedure to cleaning the data and making the data available for the model or for the solution. And then we apply some of multiple models, and then we finding the best model, and then we do the model validation, and then we deploy the model to cloud, any cloud, AWS or Azure or Google or IBM, and then it will generate the waypoint or endpoint, and a end user can use that solution at his end. So this is the deployment life cycle of, or you can say the data science or AI life cycle, the way industry is preparing solutions. So when you're trying to make your career in quantum or AI or this machine learning, you should have knowledge in data. You should have good understanding data. So data sometimes is continuous, sometimes is discrete, sometimes is time series. So we'll discuss later on this type of data. I directly come to the current artificial intelligence model. So this is somehow it is a application of deep learning or object detection. So if when we looking to any kind of image, which is a very unstructured data, so the model or the system cannot understand what type of pattern inside in this data actually. So if someone is telling that, okay, this is a picture of a dog, and you get that if the object is detected, then that means you have 100% accuracy. So generally it is comes under the lot of algorithm is there. You need to have understanding in convolutional neural network. You should have understanding in region based convolutional neural network. You should have understanding in backend structure like ResNet, AlexaNet, VGGNet, RetinaNet kind of backend structure. And then you should have knowledge in to how to train the model. You should have knowledge in GPU. You should have knowledge in computing, distributed computing, environment. So see the way we are designing the solution for this example, we need to detect this image. Here is two object is there. In previous image, there is only single object is there. This image is two object is there. So if a system is detecting person as a dog with this, these are the probability values, and this is called as confidence value actually. So if it is comes with these values and detecting the object, it means that your system, your model, or your your algorithm is working 100% accuracy. See, these are multiple object detection actually, multiple class is called as classification, object classification, and this model is called as max regional convolutional generator, is called as max RCNN. And using max RCNN with ResNet 151 architecture, this is the result. And for to train this entire things, we used a cloud platform. I'm using Google Colab Pro, and Google Colab Pro comes with a GPU with VDI is a NVIDIA Ultra Series V100, and with that GPU, the accuracy is coming, this much of accuracy we're getting it. And almost all of the models are with comes with high accuracies, but sometimes comes with some false positive. See, this is the object is here. But this model is so fine-tuned, is you can see that this is hedgy and this is very blur is there. But with this blur and with hedgy nature, this object is detected as a person, which is absolutely correct, and with high accuracy is there. See, this is object is a person, and umbrella is detecting this way. But sometimes what happened, the master data set that we what like it's a issue of supervised learning. If your how the it's limited with the data, actually, how the data limitation is there. If you train your model with Apple, it cannot predict the RN. So the Coco data set, what we use there, we are not using Lion as a data set. So what happened when we pass some picture with the lion, it detecting as a cat. So this is the false positive, things. Actually, these are sometimes it's a kind of hallucination in nature. It generally happens in machine learning. Um, so then the requirement of quantum is now, yeah, when we go with the requirement and the demand, year to year the demand will be higher. And now you can see that there are a lot of social media platform is there, where we're using a lot of data. And these are the case studies we're getting it. And the data utilization is very much higher, and it is expecting that in 2024, end of 2024 and end of 2025, we have 6G, and the devices will be very fast, or very high conflict mobile devices will have in 2025 and 2026. And the amount of data will be very faster. And this data analytics tool that currently we have, that must and be ready to come with the output with accuracy. So for that region, the quantum is needed. There are a lot of investment already done in quantum, and it is started in 2013. And these two big player, IBM and Google, are already in this competition, and they already comes with the quantum. A computer will be in commercialized in 2025, end of 2025. So there are a lot of research strategies and plan already there in India also. See, I should not go with this study because it takes a lot of time to sharing the demand. The demand is in a very short form. The demand is very higher, and it will be higher in 2025 onwards. The demand will be very higher. It will be higher in a lot of areas like oil and gas, sustainable energy, chemical field, pharmaceuticals, healthcare, telecommunication, financial services. Like, these are the things. These are the domains where data will be very higher, and the classical computers cannot be a right solution for that. When you have you need a high configured RAM, you need a lot of space. Right now 8K videos are coming, is very high, right? 5 years before, 4K videos are not able to operate in mobile, but that is now possible. And this way data will be very higher with respect to image and video. See, when we are discussing about the concept, see, these are the algorithms is there in quantum machine learning, quantum principal component analysis. If we change the quantum to is quantum, because I will explain the quantum concept here. So if we talking about genetic algorithm, if we introduce quantum concept, is called as quantum genetic algorithm. If you introduce quantum concept in neural network, it's called as quantum neural network. So what is the difference between a neural network concept right now, and what difference between a quantum neural network? There's a huge difference actually there. Okay. in terms of the classical bit and quantum bit. See, so when we are talking about quantum computing, there are a lot of terminologies coming. It's called as superposition, interface, and entanglement. And with this concept, the entire quantum computing is based on. And now a lot of players are there: Google, Amazon, IBM, Microsoft. They all are in this competition, and they already a part of quantum computing. But IBM is a little bit faster in this way. They have their cloud system here. I will explain that cloud here, how we will do quantum computing, how we'll get the access in IBM. See, the quantum computing is how it is works. Like, I'm giving a small example about entanglement and superposition. For example, if you want to finding uh, or if you want to measure the distance or something about a object in a space, by using the quantum mechanics concept, you should go with either spin up or spin down. Spin up means you can take at 0, and spin down maybe is 1. Generally, what happen in classical computing, these binary bits are associated. So the way I'm representing my presentation and using the laptop is based on classical computer, and it's in backend. This screen, this whatever we are, the graphics is converting to binary bit in backend. That is the machine code is as a backend. The embedded system is working that way. So the all are the bits is based on the binary bit actually, and the output always be in the form of 2 to power n possible permutation. And somehow when your data is very higher, it cannot manage that type of computation. But if you go with quantum, like the superposition, like the spin or spin down, when you try to finding the measurement of an object, you can either go with spin up, either go with spin down in a spherical orbit. And with respect to a particular angle, you can immediately get easily that position. And that position is called a superposition. So superposition is called comes with always a spin up and spin down combination. For example, I'm giving a very good example here to understand the quantum entanglement and superposition, and how it will be impacting the business in data related analytics. You will get this idea. For example, if you want to suppose you order 2 items, food items from online. You want at a time dosa and bada, at a time you order it from online, and the delivery boy comes with 2 packets. One packet is in dosa and one packet is vada. So without opening that packet, can you have the idea that where in which box the box is contain dosa and one which box contains that vada? It is very difficult to find out that one. But if you open one packet and you understand that this packet contains dosa, immediately got a information that this another packet should have vada. And that is by taking someone's information. If you get if you predict, or if you have the idea what exactly the next packet information is there, that is called as entanglement. So quantum entanglement immediately gives you idea that, okay, if this packet have the information, then that next packet, what will be information is there. So it will be very highly impacting. And this way you can imagine that how faster it is compared to classical in a computer. So when you predicting someone's positions by taking your initial position, that called as superposition in nature. So these concepts is there in quantum mechanics. Now it is converting to quantum computing, and whatever the algorithm associated to quantum computing is called as quantum machine learning. So for example, if you develop a algorithm to detecting the fraud activity, the classical computers or classical machine learning takes much time, because it always is, it has no ability to finding or to predict someone's information. Always it needs to open the packet. Every time you need to open the packet. So opening a packet, get the information, then wait for next packet, opening that packet, getting the information. So that's why it is very difficult to identify the fraudulent activities and in cybersecurity. Suppose in future we get the quantum computer and we have quantum machine learning, what will be happening? By opening one packet, we'll got the information about 1,000 packets with entanglement concept. So this is the beauty of quantum machine learning. I'm giving a very good example, a real-time example. That's why you can easily coordinate what is the difference between a classical computing and quantum computing. So so when we discussing this terminology, like this one, this is the concept. This is spin up, this is spin down, and these are the probability associated with the spin up and spin up position, and this is quantum state. And to measure this quantum state, you need to define the entanglement and the superposition, and this way you can define the system. So this way you can design your computing, and this way you will faster the computing. Then let's discuss about the idea about binary. What binary actually? Let's try to understand in terms of image, kind of image. So if you look at these two images, you may not have the difference between two images, but one is grayscale, one is binary. This is binary and this is grayscale. So see, when we have a binary, most of the image is black and white, but in grayscale you maybe have the background as a little bit gray in nature, and your image is prominent, and you can have a clarity of image. See this, there is a crack in nature here. It's a tool, and by taking the picture there's a little bit some there, but in binary image you have no idea about what exactly this one. So when you consider about the binary data, that means how it is very simple in nature. You can make a correlation with this image. And if we change this data, what exactly binary and grayscale? Grayscale is a combination of some decimal number and with 0 and 1, where binary is only 0 and 1. So if we take this example, see this is the somehow it is the operation of binary and somehow it is the operation of grayscale. If you change something, this value, generally it is comes with 0 to 255 value in grayscale, and this binary is 0 to 1. Okay, the dimension. So there will be nothing you need to change in binary scale data. If you make it to 0 to 1 and 1 to 0, you will make this color will be changed to white, and this white may be changed to black. But here, if you change some values, you will get this edge. So right now, whatever the tool are using in your mobile to do image enhancement, you need to change these values, and you need to change the sharpness and brightness in the data. So when you move from binary to grayscale, definitely there is a scale up in the data. And when you move on from binary to gray and gray to color, you will have the three-dimensional picture in there. So this way, when you have high dimension of image in nature, like right now we have 4K, 8K, and 16K image also already generated. So right now there is a issue with medical image processing. The devices is not that much of smart enough to generate color image. Right now there are some development is there. Some critical medical diagnosis comes with color image, like your cancer cell detection comes with color image right now, and that's very costful. All our machine are all are very costful. So see, like in future, if you introduce this quantum computing and do this analysis, we may not need that type of high computing, high cost instrument. By taking that position of the data, you immediately get it that from binary image or from grayscale image, we can get what exactly the tissue will be there. We should not depend upon the tissue color or the cancer cell color, because recently we have a discussion with some medical professionals. they need to do the layer by layer operation in image so that they can understand where is the issue is there. So that type of arrangement right now very high cost percent, paying a lot of cost for that to identification of the problem is very important in healthcare. If you're not able to get it in which state the cancer is there, you know, the doctor cannot, they may not proceed with the solution, in an appropriate way. So with quantum concept, any kind of that idea that okay, these are, suppose you can treat this as a thin layer, uh, you know uh, suppose there is some issues with your bone, and if there are a thin layer breaking in the bone, so it can be easily detected by this algorithm and this concept. There are a lot of concept is there, very mathematical is there. I should not go with this. It will be take more time. But there are a lot of advancement is there, like D-Wave launch 28-bit quantum computer in 2007. Already IBM have 20 qubit system, and then it has also GUI interface. Google has also quantum AI lab in with NASA, and already they have launched their program 2013. A lot of advancement is there. Um, come back to the you know the way we need how we will do the programming for quantum machine learning or quantum computing. One is you can go with QSkit. Mm, QSkit is there. So it is free of cost right now for students and for professionals. You need to register yourself, and if you go with your organization, those are professional, you may not get it, so that you can use your high school or your college name or your university name for to get a free access in QSkit. It is only free of cost for the students or researchers right now. The IBM is a cloud in IBM, cloud support. Whereas Microsoft also have its quantum kit, but it is not free of cost for everyone. You need to be pay some money. If you want to do some exercise with quantum computing, you should go with QSkit. You should go with IBM, and you need to, if you want to do with your local system, you need to install the Jupyter lab, studio or Jupyter code, and you need to install the QSkit directly with pip install, so it will be installing this way. But there is one issue. What will be happen? Like you need to see there is one issue with your local system. If you want to do with your local system, your RAM should be 32 GB. If your RAM is less than 32 GB, you cannot coordinate with the IBM QSkit with your local system. But there is a way you can do your practice. For example, I'll come to this example. For example, you need to you need to register your name in. I think I mentioned that link here, but it's not showing. This is quantumcomputing.ibm.com login. So we'll get a window like this. Okay. Now, after getting this window, we'll go for sign off the ID. So I put my username, password, or like that. Then it will comes with your verify your email. Then after that, it will ask this user agreement. You can say that okay, accept and continue, and then you will get a message like this, welcome. So here you can get a quantum cross composure and get a quantum lab. So if you do the composure, means you will get the quantum related things. But if you go with that quantum composure, you need to go with the mathematical concept. That means you need to convert each your problem to quantum related circuit gate. Without quantum circuit, you cannot do the quantum computing here. I just suggest you that if you do some programming activity with Python, then you can go with quantum lab. So you'll will get it this link here. You can see that it will be get quantum QSkit 3.4 4.2 is advanced version, and you can open this Python link here, or you can open this link. QScript 3.4 is a Python console actually, and you can do your coding here. I'll show you the example. What I did here. This is called as function approximation actually. So if you know a known system and you develop your machine learning application, and you need to validate your machine learning application with a known system, then you understand that okay, my code is right and my system is behaving well, because you know this system actually. So you know what is the behavior of sine function. So you know this is the behavior of sine function. And if you design a machine learning algorithm here, maybe it is a support vector regression or support vector machine, or radial basis function or CNN model or anything, and if your model behave similar sine function, then you said that okay, my model is right, or my model is good, because it's behaving this with respect to this known function. So the known function is a sine function. I added a noise here, so I got y. I know what is y and what is x, but the system, the model, it has no idea what is y. So when you pass your x to here, this x input, it generate a prediction y cap. So this digit minus this prediction will get an error, and this error need to be minimized by using any kind of optimization method. In neural network, people are using backpropagation algorithm to minimize the error. In linear regression, people are using ordinary least square method to minimizing the error. So generally what happen, the way it is there. So if I say that okay, wx plus b is nothing but your regression line equation. So you need to tune this weight and bias, so that after some iteration is over, your this y, this predicted y should be behave like this y, and the error should be minimum to zero. This way you can design the model. So this output, this is the code I written down in my local system, and I found that okay, my model is good. So what do I will get it in quantum actually. So in quantum, my system should be very faster. So what I did, I generate a same IPython file here in quantum, and I take it to there. But to designing this system, see, this is the difficulty of this one. That's why right now people are paying a lot of money to quantum machine learning engineers or quantum computing engineers. See, this way you can write a code from sklearn, you import SVM dataset, and you define your x. X is your that sine function, and I added the random noise here with this x, and I generate the y. And when I got the y, then I defined the subproductor machine regression with IVF kernel function, subproductor regression with linear kernel, and subproductor regression with polynomial kernel. And then I fitted this. I just use here the radial basis function only, the subproductor regression, and fit this x and y, and I got the model. So this is very simple code. I write it down here in Jupyter notebook. But if I want to go here for this quantum computing or quantum machine learning, I need to define this gate. This is called as quantum Hadamada gate. So you need to define a gate, like AND gate and NOT gate, or else you will not get the connection with your x input to y in or y output. That's why you need to define a lot of things. So in future, if a dedicated if you arrange any dedicated workshop for this, I will explain how you will design a quantum computing related circuit design. Circuit is design. See how it will be, like to design a circuit. Like, see, the circuit is like, I'm just explaining this one. Yeah, see, suppose this is a neural network architecture actually. So these are the inputs you need to define here. and these are the weights associated, and you make a summation here. This is called a neuron, and here you can add a bias, and it will be W0 into I0 plus W1 into I1 plus like plus Wn minus 1 into this one In minus 1. Okay, these are the summation plus bias. If it's a one single neuron, it is a bias. Okay, then you pass this to threshold function. Okay, and you get a value. This is the code I written in Jupyter notebook by using scikit-learn. But for quantum, I need to define this up spin and down spin, the qubit, and I define the entanglement here, and I define a measurement here. Without that, I could not convert this neural network to quantum neural network. So I did this here. So that will be take a separate discussion. It will take more time to explain this concept here, but you can see that I call all of the like I use a PyTorch version here. I define the tensor and the lossless function here. Then I call the quantum circuit. I call the quantum instances, algorithms, parameters, then measurements, everything, and the same code I run it and I got the result. So it is the way the model non-model is. You can see the red color is the round model, and these are the blue dots is the model output. So which is very faster compared to classical computing. But if you want to make your local system with this QSkit, you need a high configured computing device local system to run it. So what we'll do, like, let's come to the carrier point of view. What you need to do to make career in this particular field. So generally you need to have a hands-on in programming. You pick up Python as a programming tool, because you see that it has support Python. QSkit is support Python. Okay, whatever the model, everything you need to do it, you can use Python. Then you need to go with any kind of image related. OpenCV is for reading the images and analyze the images. NumPy reading the numerical data and the data related kind of that, multiplication, division, derivatives, integration, high level kind of mathematics. Then scikit-learn is for machine learning tools. Matplotlib for it's for graphical presentation of your data. The C1 related to your data frame. Pandas is meant for the data frame. So this is about the programming environment actually. Then when we're looking for data analytics kind of that, you should have a good knowledge in R Studio or R. And for deep learning kind of that, you need to have hands-on on PyTorch and Keras and TensorFlow. And for ID, you should any kind of Visual Studio or Jupyter or PyCharm you can go with. And for integration, continuous integration, you should have Git, Jenkins and GitHub and Docker. Containerization process should be there. And for big data and high data distribution kind of that, you should go with Spark, Hadoop and Scala. And for API development kind of that, you should go with Flux and Django. And for cloud, you should go with AWS and Azure. So what exactly you will get it from this in carrier? What you can get it from? Like if you today you try with quantum and quantum computing, do practicing in cloud and get knowledge and little bit knowledge in, like, when you have the mathematical concept, when you have the clarity on that, you will definitely, there is not big things to make the quantum circuit actually. Without quantum circuit, you cannot make the connection actually. You may not do the measurement. That's why little bit kind of that. So today's session, it is not a part of that. So in future, I will cover that one. But in terms of career point of view, what type of position, what type of designation, what type of job you looking for? you can start as career as cybersecurity engineer. I already told that how the quantum entanglement is helping to finding the fraud, to getting it any kind of threat related issues. So cybersecurity engineer is a kind of a very right choice for this. Then quantum development representative, product marketing engineer, quantum processor engineer, data scientist, research scientist, one of the best, where you get a lot of very best salary you are getting, right, people are getting right now. And quantum cryptography is there, is a very fantastic field, you will make your career. Research portfolio manager, program manager. So these are the, this is not I coined this, the designation or this job title. These are the uh, you know uh, these are the job titles available in Indeed, in Naukri, or any job portal. You will get it. These are the terminology, and for that you should have the basic knowledge about this. And I think TimesPro will covering this one. So what exactly you need to you need to upskill your things in AI and machine learning. You should have good in programming language, providing statistics, data modeling, evaluation, machine learning algorithm, distributed computing, advanced signal processing techniques, cleaning, manipulating, extracting the required data, developing code for data analytics and manipulations, analyze and check sustainability in algorithm, okay, clear code algorithm, and you should have some kind of publication in research articles, like because it's a kind of a research oriented position. It's a kind of advanced AI kind of position, who are good in mathematics. I believe that all are in engineering discipline. So whoever, if you are BTech in electrical engineering, good in BTech in electrical engineering, go ahead in this. You will have, in future, this is the future actually, and you should have knowledge about data understanding, data visualizations. So in that, you should have good into Python, good into libraries. You need to have good skill to read the data, text, HTML, CSV file, generating data using Panda, Excel, and data visualization using Seaborn and Matplotlib. Then you should have good knowledge in data cleaning. Then you should have knowledge in cleaning the noise and outlier, box plot, detection of outlier. Then remove the null values from pandas, missing values, dealing with missing values, and data statistics. If some columns are in bad, if it is missing and is very bad in nature, then you need to change the column name, drop the column. So there are a lot of operation in pandas actually, and pandas is required to do the automations. Whatever you did in Excel, nobody's looking for that one. If you can also automate Excel using Panda, um, and in AI machine learning, you need to have good knowledge in algorithm. You need to have understanding about supervised learning, semi-supervised learning, reinforcement learning, on-supervised learning, and the libraries like scikit-learn, matplotlib, tensorflows, keras, pytorch. See, the pytorch is used in quantum, shogun, confusion matrix. You should know about classification, regression, what exactly, how to measure the performance in classification and regression. For regression, you should go with root mean square as a performance measure. But if it is in data science, in classification, you should go with confusion matrix and accuracy, recall, kind of that. Supervised learning methods, you should have good understanding in linear regression, multiple regression, logistic, Navier-Weiss, Gaussian, supervector machine, decision tree, random forest. All of ensemble machine learning knowledge would be have in this area. Then supervised learning in that MLP, multi-layer perceptron, radial basis function, deep neural network, convolutional neural network. You should have good knowledge in that, because without deep learning, you should not go with generative AI and Gen AI in nature. Unsupervised learning means clustering, K-mean, fuzzy K-mean, KS, principal command analysis, independent command analysis. You should good knowledge in that. And ensemble machine learning, like you should good have in random forest, adaptive bagging, tracking, and active learning and incremental learning using Python or in R. Then the little bit advanced is here. Computer vision and deep learning. You should have good knowledge in convolutional network, encoder decoder algorithm. Then the region-based convolutional network like RCNN, FRCNN, MRCNN, object detection algorithm, computer vision algorithm like OpenCV, PIL, SKMS. You should have good understanding in that side. Image segmentation. Then let's you should have like when you are talking about computer vision and deep learning, you should have good knowledge in natural language processing and test classification. So in NLP, you should have lexical processing, regex, tokenization, bag of words, TF, IDF, phonemic test hashing, streaming lamination. Like whoever have looking for generative AI, people are talking about generative AI, then natural language processing is must. You should have a hands-on in natural language processing, post tagging, then Markov chain process, then what to vectorization, topic modeling, probability slant sentiment analysis. These are the things you need to be have a clarity, and you should have hands-on on this. So this is all about the requirement, and the advanced position is coming right now in outside India. These are the opportunity in quantum, right? Quantum machine learning scientists. You should have good in quantum algorithm, in machine learning algorithm. Quantum software engineer is coming very soon. Then you should see that QSkit, QML, Python is very important. Then qubit researcher is there. Then quantum control researcher is there. Quantum error correction researcher is there. These are the positions recently it is coming. Then quantum cryogening engineer. Cryogening engineer, all if you know, is using space, and their cryptography kind of heavy requirement is there. Then microwave engineer is there. So everywhere is there. If it is related to do some kind of finite animal analysis, you can introduce quantum is there. These are the things. So with this, thank you. Over to you, Bimlas. Any question if you have, we can discuss.
You can raise your hand in case if you have any questions. Yeah, Lalit Saho has a question. Yeah, Lalit, you can just unmute and you can speak.
Yeah, please.
Yeah, I have a question is that, so thank you, sir. Actually, it is very, I am very happy to join this session and I get a lot of knowledge from you, which is very helpful for me. And one question is there, means why it is quantum computing? Is there any relationship between the quantum physics and with this new technique of quantum computing?
Yes, you're absolutely right. It has the relations with quantum physics, quantum mechanics. As you know that computing is two types. One is classical. The way I'm presenting the things like binary image, you can correlated binary things, right? So when you are talking of binary image, so you can see that how it is very hedgy, right? You suppose there will be two picture you will share with a friend. One is binary image, one is color image. Which image your friend will be like? Your color image, right? Similarly,
Yes.
classical computer comes with binary bits and somehow related to hexadecimal values are there. But dealing with hexadecimal and binary is very slower compared to quantum. In quantum, what will be happening? It comes with qubit operation. So one qubit is equal to 16 times faster than classical bit, because it comes with two positions. One is spin up and spin down, 0 and 1. The test will be the state diagram of classical computing and quantum computing is different. You know what is state space diagram, right? So when you searching something in a state space by defining its constant parameter, you will searching something, right? So the searching is very slower in classical computer. For example, today you have a banking transaction, okay?
Yes.
And if fraudulent activity happen, so the cyber professionals are not finding that frauding activity, right? It is very slower process. They are not able to identify the position. So today, someone showing position in US to within fraction of second, it's showing position in France. Fraction of second is showing is position in UK, like that. So the classical computer, what will be happening? It opening a one packet, getting the information, waiting for the second packet. Packet information, you know, the internet or any computing
Yes.
related, it comes in the packet of information.
Yes. In
So
a
if
way,
you
yes.
yeah, exactly.
Voice converter.
So yeah, exactly. So when you open a packet, you got the information. But in quantum, you opening one packet and you get all the information. So if a fraudulent activity happening today, and I know that the IP address, something like that, I opened the packet and got entire information, so I can immediately catch up if he's sitting in any other location in India or anywhere else. So
And
the
one more question.
yeah.
Yeah, I got my answer. So one more question is coming to mind. So as we learn in our microprocessor, we are using the logic gates, and these logic gates actually using that binary digits 0 and 1.
Exactly. Yes.
We are using that and NAND or JOR,
Mm-hmm.
that logic gates, and using those logic gates we develop that microprocessor. But
Yes.
in quantum computing, we are using a different qubit.
No, no,
So
no.
how?
In quantum computing, you can convert that to quantum. There are other gates are there. Hadamada gate is there. Then C node gate is there. So you can easily complete a circuit with faster. So there's that person I have not complete today. So in future, if Bimles arrange one more workshop for dedicatedly for this quantum, definitely that session will be covered in that side. But you are absolutely in a right direction. The microprocessor's logic gate is NAND and AND gate, like that. You can also convert that things with quantum. Okay. With QSKIT, you can convert AND gate to quantum AND gate. You can convert NOT gate to quantum NOT gate. Okay.
Okay, got it. Thank you, sir.
Any question?
There is one more question, sir,
Yeah.
in chat. How this question has been asked by Bhupesh. How mathematics play important role in quantum computing?
It is a little bit important, without mathematics, engineers has no identity, right? Whether you are in a ceramic engineer or in a computer science engineer, mathematics is required. So definitely some mathematics is there, particularly to calculate the superposition, to defining its measurement, and defining its entanglement, because it's a complex complex number. All of you know complex theory, right? Like it is in a sphere. If you cut it in the mid position, you will get the value of expansion function, e function, right? That similar way you can got the superposition part. So complex number is there. Then yeah, integration, little bit integration knowledge is there. Derivative we should know. So these are it's not higher order mathematics is required, but statistics is required. So I think these are the mathematics required. That's not a big issue here.
Thanks, sir. Great. I think I cannot see many more questions. In case if
Okay.
you have any questions, please post in chat. And in the quick time, I would like to introduce one of my colleague, Aishwarya, who would like to quickly talk about one of our quantum computing program. Aishwarya Pathak, over to you.
Hi, Vimlesh. Thank you so much. And thank you, Dr. Santosh, for such an amazing session. I'm sure our learners got a good insight on how they can get in the field of quantum computing and machine learning. So, hi, everyone. So, as we spoke about the successful careers in quantum computing and machine learning today, I am here to talk about one of our successful programs that we have. So the program that I'm speaking about is IIT Delhi certification in quantum computing and machine learning. So as we know that quantum computing propels computations to unimaginable speeds, while machine learning fuels intelligence through data, right? So together, these two are reshaping the industries, fueling innovation, and solving the intricate problems, right? So you can deep dive into this extraordinary domain with the program that I am going to talk in detail about, right? So as per Global News Wire, global quantum computing market size is expected to grow by $143.43 billion by 2032, giving us endless opportunities to start working in this field. So talking more about this program, so this is a 5-month program which is tailor-made for individuals who want to learn about the future of computing or are interested in careers in quantum computing and machine learning. The curriculum covers topics like quantum computing, quantum algorithms like Simon algorithm, quantum deep learning, and quantum machine learning. You can learn the fundamentals of quantum computing and machine learning and the real world implications of these two combined together. With the help of hands on projects, you will get access to industry insights that will be delivered from a renowned IIT Delhi faculty via live online sessions. And this just does not stop here. By the end of this program, you will be equipped with various quantum computing algorithms, and you will also be able to differentiate between conventional computing and what quantum computing is. This program also gives you the opportunity to have a 1-day campus immersion at IIT Delhi campus where you will get to meet your faculty and peers and network with them. By the end of this program, you can actually prove your expertise with a certificate of completion, which will be an e-certificate issued by CEP IIT Delhi after you complete this program. So if you are somebody with a strong passion for emerging technologies and or a professional already working in the field of data science or analytics, this program is definitely for you. We have actually had learners from various industries in this program, such as information technology, financial services, education management, to name a few. And after this program, you can actually work on roles like how Dr. Santosh actually told us about what are the career opportunities that we can get. So, to name a few, we have quantum machine learning engineering, quantum data scientist, quantum consultant, right? So, and I'm really proud to announce that we have already launched 3 successful batches of this program, and we will soon be launching the 4th batch. So, please go and grab this opportunity to explore this program and sign up for this program if you are somebody who is actually looking to get into this career. I would also like to take this opportunity. I remember Dr. Santosh speaking about Gen AI. So we have a program which will actually help you again deep dive into the field of data science and machine learning. And it will also speak about Gen AI. So we have a successful program running with IIT Roorkee, which is a certificate program in postgraduate certificate program in data science and machine learning. I'm really proud that we have launched. This is the 8th batch that we will be launching soon. So if you are somebody who would like to work on real world projects, because this program has it will give you practical hands-on learning with 10 plus high impact projects with 2 specializations you can choose from. With one is deep learning applications, which will be with image and speech, and the other specialization is data engineering. Apart from that, you will get to know about text analytics, advanced machine learning, foundations of data science and generative AI. We also have hackathons in this program. So if you are somebody who wants to explore this program, please go ahead. And this program will also again give you the opportunity to network with your peer with a 5-day campus immersion opportunity that you will get. And you will also get a completion certificate from CEC IIT Roorkee that will actually help you uh, to get a push into this field and get a career into it. So I would leave the links of these 2 programs with Vimlesh to share with you guys. And if you guys have any questions, you can reach out to Vimlesh or you can drop it in the chat and we'll take it ahead. Thank you so much, Vimlesh. Over to you.
So thank you, Aishwarya. And folks, I think we are already running out of time. I can see still a lot of questions. So feel free to join our community. I have shared our community link with you or a chat. So please, whatever the questions which have been not answered today, I request you to join our community, and we have a dedicated channel for Q&A. So please feel free to drop your questions over there, and we'll address all your questions. And related to the program which Aishwarya has spoken right now, I'm just gonna share that program links also on chat. So please do join our community, and we will be posting today's session recordings, as well as we'll be sharing the materials and other other tools for you guys for the free of cost. I think by this we will come for end of the session.
Yeah. Thanks, Vimles. Thanks, Australia, for this wonderful, information to this all the all the candidates joined today. One more thing before I leave, I just quote someone I follow, Dr. APJ Abdul Kalam, and he said one thing, that if you want to change your economy, your family background, or your career, only you can do with your learning. If you have more learning, definitely get a good position in your life. Follow APJ Abdul Kalam's suggestions, and whatever learning you can get it, learn. Life is very big to grab knowledge. A lot of things are there, and Privilege will be help all of you. You connect with Aishwarya to get more details about it. All are the IIT's program. It's fantastic. Definitely get a lot of insight from that program, and wish you very best for your career. Thanks a lot.
So thank you so much, sir. Thank you so much for your time and for the
Thank you,
insightful session.
thank you all. I'm
And
leaving. Over to
yes,
you.
sir. Yes, and I would like to thank all the attendees who have taken out their time and to join us on this Saturday morning. And thank you all. And I'll see you again in the next week with a different topic. So stay tuned. Have a good weekend. Take care.